I'm going to go through some of the integral test review questions. I already did this once and my cheap program didn't work. So I'm just going to show you a couple of the items here and then work down through some of the other ones. The first one is a particle motion problem. And when we have integrals, you're going to work backwards from either the velocity or acceleration, usually, and not work from displacement. So in this case, we are finding the total displacement, or where we're at in displacement, and then our distance, which is total displacement. Remember to set those up as one is the integral of velocity, the other one's the integral absolute value of velocity. So the integral of velocity, straightforward, set the integral. That's going to end up with a position. It's going to have positives and negatives, and I'm not going to integrate that and plug those in and let you figure out the arithmetic. You can do that by watching something else. The second one is the one we got to be careful with, absolute value. We got to find where the zero happens here. The zero happens at 7, so you need two integrals, one from 5 to 7, one from 7 to 11. And this is going to give you everything above the x-axis, which would be the distance traveled, everything positive. And on the second one, I'd set them both up and then use my calculator to finish it off. Second question on here, finding the particle moving along a coordinate line, acceleration function. So if we're finding position, that means we're going to integrate twice. If you integrate from acceleration, you get velocity. So this is a particular solution problem. They give you some information. We have the acceleration. We have initial conditions 0 and 120. So as you work backwards, the integral of acceleration is velocity. So 3t squared plus or minus 46t plus a constant. This information right here plugs in to give you your constant. So this is the velocity function. When you integrate, you get displacement. Initial displacement, s sub 0. I called it d, but s sub 0, if you want to call it that, is 0. So our c is just 0. So your final answer is a function. Okay, next one. For each problem, approximate the area under the curve over the given really 4 right endpoint rectangles. So a Riemann sum with fixed rectangles. So if our interval is from -2 to 2, and we're doing 4, each of your rectangles has a width of 1. So we have 4 rectangles with a width of 1, and we're doing right endpoint. It's an approximation. That's how we know we're doing rectangles. So I would just use my table if I have it, which I do. Put in x squared over 2 plus x plus 1. Set your table to start at -2 and go by ones. And so we're going to use the 4 right endpoints. We're not going to use the -2 value. So we'll use the 5, the 2.5, the 1, and the half. And so each of the widths is 1. So just basically adding the heights together. So 1.5, 4, that equals 9. That's the right interval. If we were doing a left interval approximation of the same question, we would have used 1.5, 2.5. We just wouldn't use the 5. Evaluate each indefinite integral. It's a straight integration. See how much time I can get these on here. Looking for quantities or angles. So in this case, angle u equals x to the third du 3x squared dx. So dx equals du over 3x squared. Ready to substitute. 6x squared sine of u, that cleaned it up, and then dx is du over 3x squared. Cancel out your x squareds. So we have the integral of 2 sine of u du, which would be negative 2 cosine of u plus c. Plug in the original u value. That's your answer. Indefinite integral. So we just have a function there. We need more information. Second one looks complicated. Got a lot of writing. But u equal 2x to the fourth plus 1. Again, follow your rule for trig. Du is 8x cubed dx. So dx is du over 8x cubed. Substitute back in. Integral 24x cubed cosecant u cotangent u du over 8x cubed. Cancels those out. So we have the integral, put the 8 out front, of cosecant u cotangent u. Think about what has a derivative of cosecant cotangent, which would just be negative cosecant. Final step, put in your u. So it actually ends up being not terrible, even though there's a lot of writing. The initially, not bad. I'm not going to finish this one here. U equals 4x to the third plus 5. Pretty straightforward substitution. Evaluate each definite integral. Fairly straightforward. These you can check your answers. If you're making a mistake, it's probably arithmetic. Make sure that you integrate and subtract a whole quantity if you're off by a little bit. So this capital F means find the integral. This one is a little bit tricky because it's two function values, but remember we can split this up into that. So we can treat this now like our own absolute value rule. 2x minus 4 changes at x equals 2. So you're going to have an integral from 1 to 2 of negative 2x plus 4, and the integral from 2 to 7 of 2x minus 4, and then this integral from 1 to 7 of negative 2x. Should keep you busy for a while.